Hey there, this is Math 7, Unit 2, Lesson 13, two graphs for each relationship. And so we are looking today at using tables and equations and graphs to answer questions about still proportional relationships. We're looking at three things: tables, equations, and graphs to talk about proportional relationships. You began today with a little warm-up looking at fractions and decimals, and so that's what you did today in class to start off with. And then you moved on to your first activity, which is called tables, graphs, and equations. In this activity, your teacher assigned you one of 3 points for you to graph, put on the coordinate grid down here, and from that you're going to fill out a table and talk about what you noticed. So for example, and I won't do all these here, but A was listed at 10, 4, so that's over 10 in the x, and up 1, 2, 3, 4. That's where point A was at. B was over here at 4, 5, so right there is where B was at. And C was at 8, 5. So C is right here at that point there. If you then connect the dots and draw your nice lines, then the A graph, or the A point from the origin, would look like that. The C one would be about here, and the B one would be about here. Again, you were just assigned one of those points, and so you plotted that point there. You used your ruler to line up the point with the origin, and you drew the line that starts the origin and went through your point. And they said to continue to the edge of the graph, so this would just continue on, and continue on. Okay, and then I wanted you to complete the table with the coordinates of points on your graph and use a fraction to represent any value that is not a whole number. So for me, I'm going to go ahead and just do, this is the graph A, 10, 4. And so when x was 10, we knew that it was going to be 4. When x is 0, we know we are at 0. And so for our y over x value, we don't have one there. Now, the thing we want to take a look at is, as you look at this little line here, are there places where you see they kind of come together? Places, for example, where you're at a point. So I have a 5, 2 right there. So I know at 5, I'm also at 2. And that's really the only place it crosses. So in order to complete this table, what I'm going to have to do is look at my xy relationship, and I can look at the one down here to know that I'm 4 over 10 or 2 over 5, and that y over x relationship is proportional. We often call that our constant proportionality. So if I multiply these other values by 2/5, right, or by 0.4, I could do 0.4 2/5, then I end up here with a 0.4, and my y over x is still 2/5 or 0.4. If I multiply this one by 0.4, I end up at 0.8, and we can see there's a pattern here. I'm going 0.4, 0.8, going to be increasing by 0.4 each time. This becomes 1.2, 1.6, 2, 2.4, 2.8, 3.2, 3.6, and so on. When you do the y over x value, what you have is 0.4 all the way down. Or, in terms of y over x, it's also 2 over 5 all the way down. So that continues to go through there. When I want to write a proportional relationship to describe what's happening, or write an equation, sorry, to describe what's happening here, our general format is the y equals rk, our constant proportionality, times x. In this case here, my y value is just going to say y. My constant proportionality is going to be 2/5 and x. So that becomes what I've got there for A. Now this is just for A. My other ones, if I was going to talk about B, for example, B is going to be a y, and I look here at where that's at. I have a point for B. B is at what? 5, 4. Okay, the y value is 5, the x value is 4. So B is at 5/4 x. C, we're looking here, is at 5/8. So C is y equals 5/8 x. So they're actually, each one has its own little equation that you can use to help you determine, what the equation is for each line. And any value of x you want, you can pop it into this space here and solve for y. And that was the first part of your activity there. You looked at that and then talk about with your classmates things that you noticed there with your tables. We said things like, at the table, everything begins at the origin. That's your start point. starts at the origin. That's the key thing there. We notice that they're all in a straight line, right? They're creating lines there. For our equations, they all have a y equals kx as the equation, and that k value is always what we're multiplying the x by, and that's going to be the y over x is how we create that. Okay, that's how that works there. That's the relationship there. In terms of the graphs, we can see that the larger the fraction is, the value for the slope, the steeper the line. So our lines just went from here to here to here, and when we looked at the slopes for those three things, we had a variance there for what those were. So for B, we had 5/4. For here, we had 5/8, and over here we had 2/5. Okay, so the greater the number, the steeper, the more upright the slope is going to be. This is my smallest fraction, that's my largest number there, and so it has a steeper slope. Okay, it does say what's the y coordinate of your graph when x is 1. Well, that's simply going to be what you have as your y over x, right? So A is 2/5, B is 5/4, and C is 5/8. That's the same constant proportionality. When x equals 1, you end up with your y value there. Okay? All right, so there we go. Are you ready for more? Is the graph and equation is y equals kx, where k is a positive number, is a line through 0, 0, and 0.1k. Okay, so we're saying, all right, I have a graph and it goes like this. We've been talking about it going this way so far. But it does say that it's through, because if this is a line, it's going to continue this way through the origin, right? Here's my x, here's my y. Name at least one line through 0, 0 that cannot be represented by an equation like this. Okay? By this we mean a positive number. So if it happened to have, if the k value was negative, it wouldn't be right there, would it? It'd be someplace else. Okay? So if we could draw the graph of all the equations of this form in the same coordinate plane, what would it look like? So what we're saying is, if I drew every graph that could be represented by this, what would it look like? And so far we did 3, right? We had 1, 2, and 3. And it's like if I kept doing more, I would have more and more and more. I could have a zillion of these, and eventually I would just fill up the entire coordinate plane with lines coming out from the origin. Okay, and there's no end to that, what that could be. Because that line goes through the origin, that means each of these would also come this way as well, which means that this side of the origin would be filled up with the negatives, the k value there. And so we would have graphs that go through quadrant 1, 2, and quadrant 3, right? For how that would work. It's just interesting to think about. Okay, hot dog eating contest was next. We looked at the next thing there, and it had 2 people in a hot dog eating contest, Andre and Jada. It says that Andre ate 10 hot dogs in 3 minutes and Jada was 12 in 5 minutes. On the first graph, we're going to plot which point shows Andre's consumption and which shows Jada's. Okay, so Andre was 10 hot dogs and Jada was 12. So in terms of hot dogs, this is the smaller number, that's 10, and this is 12. And so the 10 is going to be Andre and the 12 is going to be Jada. Okay, got that there, and we label that there, no problem. Draw 2 lines, one to the origin and Andre's point, and one to the origin and Jada's point. So we take our little line here, make a line, we have 1, and we have 2. Write an equation for each line, and use T to represent the time in minutes, and H hot dogs. So remember our equation is y equals kx. So in this case, our y value is going to be the hot dogs, okay? So it's going to be the hot dogs equals, and for Andre, this point here, we said was at 10 and 3 minutes, and Jada was 12 and 5 minutes. So for Andre, it's the y value over the x value, and then our x we called time, so it's going to be t. And then for Jada, it's going to be the y value 12 over the x value 5t. For each equation, what does constant proportionality tell you? It tells you how many hot dogs they are eating per minute. Okay, so for example, Andre is eating about 3.3 hot dogs per minute. Jada's eating about 2.4 hot dogs per minute there. That's what it tells us. It's how many per minute. Hot dogs per minute, right? That's my 10 and 3. So it's hot dogs per minute is what it tells me. Okay, we're going to repeat the step for the second graph there. So same idea. But we're flipping the labels here. This becomes 10, this becomes 12. This is my 3, and this is my 5. We do the same lines this way. Oops, I should make that better. Something like that, and something like that. Okay, and here's Andre, here's Jada. Repeat the same steps, and so everything looks almost the same, except we've taken it and now we've almost flipped it and rotated it. But so for Andre, for their equation, now we're going to do t as our y value, right? T is going to equal, and what's going to happen, if you remember from our previous lesson, is we're going to look at, for Andre, it's the y value 3 over the x, which is now 10. 3 over 10. And we notice that this is the reciprocal of what I had up there, isn't it? So for Jada, it'd be the reciprocal, and I'd write 5/12 h for that one there. Okay? So we can see that the two graphs represent the same situation, but because we're changing how we label these and what's our x and our y, we end up with something a little bit different in terms of the equation and the way the graph is shaped there. Okay? So in summary, today's lesson, we're talking about here, and they give you an example of a leaky faucet leaking at a constant rate. What we're talking about today is essentially this, that even though the relationship between time and volume in this case here, or any two things, is the same, we are making a different choice in each case about which variable to view as the independent variable. And that is really what's changing. We're changing what's going to be the independent variable. That independent variable down here is the one that's going to keep on going, and if we say that the volume is independent, then we get a graph this way. If we say the time is independent, then we get this way. So that's the key thing we're talking about, but we haven't defined how we're going to do that yet. We're just saying that that is what makes the determination for which way our graph is going to go. Okay, so in this case here, the graph on the left has the volume as independent, and the right has the time as independent. Is one right, is one wrong? That's a whole other story. But for now, we're going to take a pause there. You're going to work on your homework and then come back and check it when you're ready to go. Okay, so for tonight's homework, we have, you're at the supermarket, you can fill your own Honey Bear container. A customer buys 12 ounces of honey for $5.40. How much does honey cost per ounce? We have cost per ounce. That means I'm looking at a cost per, that's my money sign, cost per ounce. That's what I'm talking about there. Do I have a cost value, a cost amount? Sure do. $5.40 over, do I have an ounce? Sure do. 12. And 5.4 divided by 12 is equal to 45 cents. Okay, so 0.45. How much honey can you buy per dollar? So we're talking now about how many ounces for $1. We want to know ounces for $1 is our goal there. I know that I can buy 12 ounces for $5.40. Okay, so to get the unit rate, or how much I can buy for one, I'm going to do 12 divided by 40, which gets me 2.22 ounces for $1. Write two different equations that represent the situation. Use H for honey and C cost for dollars. Okay, so in terms of, I looked at the cost for dollars. Okay, so cost is if cost is my Y value, then I'm going to take 0.45 and multiply it by the honey. The reason I do that is, if you look over here, this value is 45 cents. Now, this is 45, like think about it as $45 per 1 ounce, right? It's dollars per 1 ounce. If I have the H value, which I multiply by, my H value is probably going to be in terms of ounces, right? You know, 1 ounce, 2 ounce, 3 ounce. So if I was writing an equation and I had 0.45, money over 1 ounce times any number, if I made it like 3, whatever that number is going to be is going to multiply by that number to get my answer. But what's going to happen is these ounce values, these ounce terms are going to be eliminated, and I'm left with just the money. I do the same thing here for the honey one. The honey will be the other value. Honey is going to be equal to 2.22 times the cost. And again, this is $2.22 ounces per $1, right? And if I said I had $5, what's going to cancel out is going to be the dollar signs, and we're left with just 5 times 2.22 ounces to tell me how much honey is left. Okay, so we take those equations. If I just wanted to graph one, if I said, all right, here is value 1 and 1, and over here is 12, let's do the honey right there, and up here is my money, which is $5.40 for my cost. Okay, and we know that it's right there for 12 ounces. I can get, for $5.40, I can get 12 ounces. So I'm here at 12,540 for my honey cost there. In terms of my point at which I have 1 at, my 1 y comma x, or my yk, x comma k, I'm here at 1 comma 0.45 for that value right there. Okay, next up, number 2. Says the point 3 comma 6 over 5 lies in the graph representing proportional relationship. Which of the following points also lie in the same graph? Select all that apply. Selecting all that apply. Okay, so how are we going to do this here? Well, we first of all take a look and we see that for this guy here, this value, let's pull it over here, our y over x is 6 over 5, right? That's our y value, over x. Our x value is 3. Okay? I can rewrite this whole thing, if it helps you see a little better, as 6/5 divided by 3. Now a lot of you look at that and go, well, let's do our little, maybe 5th grade little trick here. So we do 6/5 times the reciprocal of 3, which is 1 over 3. So dividing by 3 is the same as multiplying by 1/3. And now when I multiply 6 times 1 is 6, and 5 times 3 is 15. You have 6 over 15, which reduces down to 2/5. Okay, so this becomes my constant proportionality, my k value, 2/5, which means I can take this value. This is my graph, or my equation. My equation for this graph so far is y equals 2/5 x. Okay, I got the 2/5, remember, by taking y divided by x, y over x, to get this 2/5 value. Now we have y equals k times x. Knowing that this is my equation, I can go back over here and put values in to decide what's going to be my solution. For y equals kx, and so we want to plug in the x value. So we're plugging in the x value. So we're going to say that y equals 2/5 times 1. 2/5 times 1 is 2/5, and 2/5 of the decimal is 0.4. Does 0.4 match 0.4 right there? Yes, it does. So that would be one of our solutions there. Yes, indeed. Okay, so sorry about that. We're going to do this again and again. Y equals k times x. Our k is 2/5. Our x is 1.5. So 2/5 times 1.5. Again, I'm messing with fractions there. And so I can turn this into a mixed fraction if I wanted to. So 1.5, that's 1.5. So this would be 2/5 times 3 over 2. I'm thinking about 2/5 there. Okay, I can cancel, and I end up with 3/5. 3/5 of the decimal is equal to, well, 3/5. I'm trying to get the 6/10. Oh no, does it match? Yeah, sure it does, right? Because I can do 3/5, and I can multiply by 2 over 2, or some teachers call it the giant 1. I end up with 6/10. So 3/5 is just a reduced version of that, so we have a solution there. Okay, and we'll do that for the other ones there. I'm going to let you do those ones there. I'll tell you this, of those 3, one of those is a solution. So as you work that out, see what you can figure out. Number 3, trail mix calls for 4 cups of raisins. So here's raisins for every 6 cups of peanuts. All right, so here's what I have. there's a proportional relationship between raisins and peanuts, okay, in this recipe. So the next question, and mine's on the next page, so I'll read it from the other place. It says write an equation. Write an equation for this relationship that has a proportionality greater than 1. So if we want a proportionality greater than 1, that means a k value greater than 1, we can look at this and we can have, if we want our y over x to be bigger than 1, then we would do peanuts over raisins, and we'd have 6 over 4 or 3 over 2. If I wanted k to be less than 1, then I could do raisins over peanuts, and I would have, instead of 6 over 4, I'd have 4 over 6, and I'd have 2 over 3. Okay? So now as an equation, what that would look like then is I could have, this one here, I could have peanuts being my y value, yx, so yp equals 3 over 2 and times raisins. Over here, my y is raisins, so I'm going to say raisins equals 2 over 3 peanuts. Okay, so that's what happens there on number 3. They just wrote it down in 3 different lines there, and mine's on a different page. Okay, so looking at the last one, number 4, here's a graph that represents a proportional relationship. Come up with a situation that could be graphed here. So this is going to be my graph about the number of days at school, and over here is minutes in detention. Oh boy. Why? Because this is going to be Naughty Paul's graph. Naughty Paul's graph. Because Paul has been naughty at school this week. Yes, indeed. He continues to do mental math with a calculator. Can't do that. Mental math. Just use your brain, Paul. All right. So Paul's been at school this number of days, and that's how many minutes of detention that he had in school. So there's my labels there. So I've labeled it, and I have given a title. Choose a point in the graph. What do the coordinates represent? So if I choose a point here and I say 20, 10, 20, 10, this means that in 20 days, so in 20 days of school, Paul has 10 minutes of detention. Okay, so naughty Paul, 20 days in school, got 10 minutes of detention for not doing mental math, instead using his pocket calculator. Man, work on that, Paul. Have a great day. We'll see you next time.